So, number 6, just to point out that obviously this wants to emit visible light, so therefore the transition has to be downwards. Okay, so the one for visible light is going to be 3 to 2. So I'm going to change that to there. Which is the following will have the same numerical value. Just thinking they've got 3s1 across the period, 3s2, 3s2, 3p1, etc. So the highest energy levels that are actually occupied, it's in the same period, then the principal quantum number remains the same. So I'm going to go for this one. Energy sublevels occupied, S1, S2, S2, P1, etc. That's not going to be true. Orbitals occupied, that's not going to be the same, S and P. So BA. How the following properties change down group 17, it's group 7. So ionization energy, as you go down, ionization is removing the electron. Obviously, as the atom gets bigger, then ionization energy decreases. It's easier to remove electrons. The ionic radius, obviously, in terms of you go down group 17, as you go down the group, ionic radius increases, gets bigger. So decreasing ionization energy, increasing radius. Question 9, how does a lithium atom form the most stable ion? So, obviously gaining protons, losing protons, totally rubbish. The atom loses an electron to form a positive ion, the atom gains it to form a negative ion. So we're just talking about the fact that, very straightforward there, the formation of a lithium ion, Li+. Which combination causes the strength of metallic bonding to increase? So metallic bonding, obviously increasing charge is increasing electrostatic attraction. So the larger the charge and the smaller the radius means it's a higher charge density and greater attraction for the electrons. So I'm looking for a charge has to be larger and the ionic radius has to be smaller to give the greatest charge density. Which molecule contains an incomplete octet of electrons? So, I suppose maybe spotting this one, I tend to go straight for this one because you've got your boron, but you can obviously think about it in terms of drawing it. Nitrogen, 1, 2, 3, 4, 5, and then you think your fluorine, F, okay, etc. So you can go the long way round. So clearly not NF3. BF3, boron trifluoride, boron group 3, 1, 2, 3, and then the F. And there you have your gap, incomplete octet. So we don't need to go any further. Bromine, the mixed halogen here, two group 7s, sulfur and fluoride. So basically those are all standard stuff, but you've got your boron trifluoride. Which compound has hydrogen bonds between its molecules? So we're looking for then the capacity for hydrogen bonding. Looking here now, the whole point as to how they've actually written these is not the obvious way of writing them. So what we've got here is obviously CH4, methane, which is standard. Okay, no hydrogen bonding because there's no electronegative oxygen. But CH4O, the only way that can be actually put together is the fact that I have to have an OH there. And suddenly then that opens up the fact that's an alcohol as opposed to your CH3, Cl, or CH2O, which, looking at that, must be then the way that is actually written, but that must be my, what do you call it, aldehyde. So the reality is this one is the only one possible of doing hydrogen bonds between molecules, so that's B. Moving on to 13. Okay, what's the standard enthalpy change in kilojoules, just these wiped out a bit, of the reaction below? So what we've got here is we've got 4Al going to Al2O3. Hopefully this has come out properly. With oxygen, and then you got your Mn plus oxygen going to MnO2. So what are we saying here? That we've actually got I've got 4Al going to 2Al2O3, so that's basically going that way is 2 times, I think it's minus 1670. Oh yeah, it must be that. Looking at that in terms of the poor quality there. Going forward that way, but then going that way, I've got 3Mn going to 3MnO2. So going that way is 3 times 520. So it's going to be minus 3 times minus 520 because it's going the other way. Okay, so just looking at how to do the sums. So minus 3 times minus 520 is therefore plus 3 times 520, and then 2 times minus 1670. So the answer 13 is D. Methane undergoes complete combustion. Question 14. What is the enthalpy change using its bond enthalpy data given below? So just looking at this in terms of the enthalpy change, what I've got here is braking. So braking is positive. If I think about that, I've got 2 CH4s. So what I've got is 2 CH4s, CH is, so CH bond is 414, so 8 times 414, that's why I'm breaking, and 3 O2s, so that's 3 times 498. Okay, they're both positive, and then I'm making bonds, so over on the other side I've got 2 times CO, which is 2 times 1077. And then 4H2, which is therefore 8 times OH, which is 463. So overall, again, don't need to work it out, but I can look and see here, I've got 8 times 414, positive, plus 3 times 498, positive, minus 2 times 1077, and then minus 8 times 463. So that confirms that the answer is C. Question 15. What's the activation? Which is the activation energy of the forward reaction? So activation energy going here is from the level of the reactants to the top of the curve. So that's B in this case. The same amount of two gases that are in two identical containers at the same temperature. What's the difference between the gases? Okay. So if they're the same temperature, then what we're talking about the fact is actually they have sort of kinetic energy, and yet the actual fraction of particles with a particular molecular speed is lower in X, which means that overall X must have a higher molar mass. So if the kinetic energy is the same, but one's got a higher molar mass, then the molecular speed is going to be less. Okay, so the answer is A. which reacts as the highest rate, the greatest rate. You've got calcium carbonate, dilute hydrochloric acid, same temperature. So obviously then you're going to have a greater rate if you've got a high concentration of HCl and a larger surface area. That seems rather simplistic. There we go. What's the equilibrium constant expression for the following equation? So it's product of the product, so that's presumably that is an equilibrium sign. So what we've got here, we can just take it from the expression itself. So Kc equals NO2F brackets squared over NO2 brackets squared times F2 in brackets. So NO2F squared, looking over here, we go to over NO2, so it must be D. What's the pH of 0.001 mole per dm³ NaOH? So the key thing is obviously that's strong alkali, so it's fully dissociated. So that tells me that the concentration of OH minus, so OH minus concentration equals what? 1 times 10 to the minus 3. Okay, so POH, if you want to put it that way, equals 3. And what is pH then? pH equals 14 minus POH. It's therefore 11. What's the major reason why the pH of unpolluted rain is less than 7? And that's due to, well, this kind of the fact that it's carbon dioxide in it. So actually, although we don't call it acid rain, it is less than 7 in terms of pH due to dissolved carbon dioxide. These other things here are pollutants, which actually take the pH lower than normal pH of rainwater. But these are actually pollutant gases, whereas unpolluted rain still has dissolved CO2. Methane doesn't do anything. So 21. Which species contains nitrogen with the highest oxidation state? Okay, so all we've got to do is work it out, I suppose, in terms of saying, well, oxygen is -2, so 3 times -2 is -6, overall minus, that's a +5. Okay, I've already said it's probably the highest, but obviously then you've got 2 times -2, -4, -1, so that's +3. This is +4, and this is +1, so we've got A. What happens to the ions of the salt bridge when a current flows? So what we've got here is this is the movement of electrons. So negative charge is moving this way, and what will happen is ions will move to balance up the charge. So that means that sulfate ions will move in this direction, and sodium ions will move in that direction. So in that sense, sodium ions flow to the copper half cell, and sulfate ions to the zinc. So that's B. The following reaction occurs in a voltaic galvanic cell. So that's an electrochemical cell. So in terms of here, which reaction takes place at each electrode? And now, in terms of an anode, okay, what's happening at the anode? I always remember this from electrolysis, just as a kind of little reminder. Okay, to me, this is good. I first learned this in terms of electrolysis, so it kind of sticks with me. So that's the negative cell, that's the positive part. And what we're saying here is positive ions travel here, opposites attract, and this is obviously the cathode in electrolysis, and what happens here is positive ions gain electrons, and reduction is gain. And anode, obviously the opposite happens, well, oxidation is loss. Now it doesn't matter whether it's electrolysis or voltaic cell, At the anode, you always have oxidation. At the cathode, you always have reduction. So at the anode, what is clearly here, at the anode, you have to have loss of electrons. So what we're saying here, and then which one is the, in terms of loss of electrons in a voltaic cell, is actually the more negative one, more reactive metal, will give away electrons. So oxidation is lost, the negative electron releases electrons. So the two metals, magnesium and silver, magnesium is the more reactive, it will release electrons, and the cathode, at the positive electrode, cathode always reduction happens. Reduction is gain of electrons. So the answer is C. Which compound has the lowest boiling point? And then we're looking at the fact that that's 1, 2, 3. That's a straight chain hydrocarbon. 1, 2, 3, 4, 5. Obviously that's 6, so that will have a lower boiling point than this one. This one is a branched hydrocarbon, 1, 2, 3, 4, 5. Okay, so that's a lower boiling point still. And this is 1, 2, 3, 4, 5. So ultimately this is the most branch and the smallest chain. So we're talking about D being the lowest boiling point. Which of the following can be both formed when bromomethane and from bromomethane and converted directly into ethanol? So we're thinking here, this is obviously our what's happening here is this reaction. If I'm going to ethanol, that kind of reminds me of an alcohol. And then obviously I'm looking at the fact that I'm just doing a substitution reaction here, and then oxidation here. So in that sense, I am looking for A. Methane reacts according to sunlight. Which type of reaction occurs? In this case, obviously, methane plus chlorine. That is a free radical substitution reaction in sunlight. A. 27. What was the name of this compound using UPAC rules? This is so easy for you, Anand. 1, 2, 3, 4, 5, 6. So the mother chain is hexane. 1, 2, 3, 4. So it's 2 methyl groups. So you've got to give both a number. So it is 1, 2, 3, 4. It's 3, 4 dimethyl hexane. So the answer is D. The following data were recorded for determining the density of 3 samples of silicon, mass and volume. Which average density has been calculated to the correct number of significant figures? So all we've got here is obviously density equals mass over volume. And the point is that the mass is in terms of sig fig, is 3 sig fig, but the volume is 2 sig fig. Therefore, density can only be given to 2 sig fig. Okay, so we're looking and saying, in which case, obviously, it must be B. Don't even do the maths. Okay, and 29, data collected from a large number of silicon samples could also be plotted to determine the density using the following axes. Which statements are correct? Okay, so what we've got here, density is the slope of the graph. So given the fact if you've got, if you plot mass against volume, you should get a straight line, because as the mass obviously increases, the volume will increase because the volume remains the same. And mass over volume is actually density, so that's correct. It's proportional, yes, it'll stay the same, and it should pass through the origin. So this is 1, 2, and 3, D. What can be deduced from the infrared spectrum of a compound? Anna, this is right down your street. What's actually here? That's all to do with NMR. That's obviously to do with mass spec, so this is the easy one, C. Okay. So, Anna, that should be you covered. Thank you very much.